Hello. Electromaker got in touch with me again and this time challenged me to create a Skittle sorting machine from cardboard. Well, what follows is my design after many revisions and far too many Skittles. Hello, I'm Lewis, and in this video I'll show you how you can build your own Skittle sorting machine from cardboard. It's powered by an Arduino Nano and some very basic electronics. The Skittles are loaded into the hopper at the top. Once the Arduino is powered on, it will start checking and sorting the Skittles by colour using two small servos. The structure of the project is made with common 3mm thick cardboard. To help you easily cut out the correct parts, I have created 6 A4 templates for you to print at home. These are then simply glued onto the cardboard for you then to cut out. If you would like to build one of your own Skittle machines, you're going to need a few parts. You can get a kit from Electromaker which will include all of the electrical components you'll need. You just need to supply your own cardboard, Skittles, glue, and print the templates for the cutting patterns. The kit box from Electromaker contains an Arduino Nano, one 360° servo and a 180° servo, a battery holder for 4 AA batteries and the batteries themselves, a TCS 34725 colour sensor, 2 push grip electrical connectors, 1 limit switch, a couple of rolls of wire and a USB cable. You'll need to start the project by printing out the 6 A4 templates for our cut parts. We'll then glue these onto our sheets of 3mm cardboard and cut around the outlines to get the shapes that we need. I used copious amounts of Pritt stick to attach my paper prints to the cardboard. After you've glued all 6 A4 pieces of paper in place, you can cut out the shapes. Don't forget to cut as closely to the lines as possible, as this is not only just an electrical project, but also a mechanical one, and the tolerances will matter later. If you're young, don't forget to ask for some help from an adult. Craft knives and scissors can both be extremely sharp and dangerous if you do not handle them with care. On some of the parts, you'll find these hatched out areas. They need cutting out. I cut mine using the craft knife. The first part that we'll glue together is the hopper assembly. I'm going to use some super glue to glue mine together, and then some hot melt glue later for the electronics. Take some care when using the super glue though, because it can be very easy to attach your fingers to the cardboard or to one another. Trust me. Each of our cutout cardboard pieces have a small grey number written on them for easy identification. For this first step, you're going to need the 4 large pieces with number 1 written on them, the square with a number 2, and the 2 rectangles numbered 3. Take 2 of the 4 side panels and glue them together along one of the edges like so. Next, take the shape panel with the cutout in and add this to the bottom. Continue by adding another of the large side panels. Now we'll add in 2 slopes for the base of the hopper. Position one of these panels just above the cutout and add some glue to fix it into place. Repeat the same on the other side of the cutout before sealing the hopper with the final side panel. That's most of the hopper complete. You just need to make a small cut through the mark in the base of our model. This is where our axle for the wheel will pass through later. For the wheel part of the assembly, you're going to need the 3 black discs, 2 of them numbered 27 and the other numbered 28. Glue one of the number 27 discs to the number 28 back to back so that the 2 black faces are facing outwards. Take a great deal of care to ensure that the notches and cutouts are well aligned with one another. Once this is dried, you can then glue the remaining number 27 disc over the top of the other number 27 so that we still have both faces showing the black sides of the paper. It's now time to grab our first electronic component. This wheel, which we've just finished gluing, is going to be attached to our continuous rotation servo. To do that, we're going to use the cross-shaped servo horn. You'll find a selection of these in the bag which came with your servo. In order to attach the wheel to our servo via the crossed horn, we're going to recess this into the centre of the wheel on one side. To do this, I roughly marked out the shape of the cut with the tip of a craft knife, and then removed one layer of material. The servo horn can then be glued into place. For the axle, which goes on the other side of this wheel, you can use either a cocktail stick or a cotton bud. You'll need to trim it to about 15mm in length. It will be inserted halfway through the discs from the other side. Use a tool to make the hole first before adding some glue and then inserting your axle about 4 to 5mm. Ensure that as it dries, it remains perpendicular to our discs. Whilst we wait for the glue on our wheel to dry properly, we can start to add some vertical supports onto the sides of our hopper. There are two parts numbered 4 for this. They are aligned with the cutouts on the bottom, with the hopper aligned to the back face and sitting on this thick black line here. By now, the wheel assembly should be dry. Attach the continuous rotation servo to the servo horn with a dab of glue, ensuring that it does not interfere with the way the servo operates. Insert the axle into the underside of the hopper through the notch which we made earlier. The wheel will pass through the openings on both sides of the stand. You may need to bend the legs open ever so slightly whilst installing the wheel. The panel number 26 is then slid in from the left hand side of the assembly, so it passes around the servo and that its black face is facing our wheels. This is followed by the two panels numbered 26. These are slid in to hold the sides in place, with the one with 2 additional notches in it placed furthest away from you. Use some small dabs of glue to help hold this part of the assembly in place. If you rotate the wheel slowly by hand through the sides, you should see that the cutouts in the wheel aligns well with the other cutout underneath as it passes. We can now fit base panel number 7 to the base of our assembly. Before you glue this in place though, just make sure that the cable coming from the servo passes through one of the 2 V-shaped slots at the base of your machine. For now, we've done with the top section of our assembly and we'll turn our attention to the bottom half. We'll start by working on the chute. For this, you'll need the panels numbered 10 through to 14 inclusive. The bottom edge of the 3 triangles needs to be attached to the panel number 11 with one on either side and the third in the middle like so. This is then fitted onto one end of panel number 12. Glue the 2 sides of the chute so that they are aligned at the top edge. Finally, panel 13 forms a cap at the top end of the chute. We can also attach a horn from our other servo to the centre of the square panel on the underside of our chute. Setting this aside, we'll start building up the main part of the lower section. For this, you'll need the panels numbered 8, 19 and 16. Add some glue along the 2 sides of panel 8 and then fit the 2 longer edges of the panel 19s to this, aligning it carefully at the back edge. Panel 16 is then glued along the front edge. Make sure that the number on this panel is upright and facing outwards. This will be covered by our servo shortly. Panel 17 is then added horizontally along the top of 16, followed by panel 18 behind this. Make sure that the cutout on panel 18 is on the left hand side when looking from the front curved edge. Panel 15 is then added onto the top of this assembly. Ensure that the end with the hole is towards the front of the assembly and then glue it into place. Our remaining servo is then glued over the black box on panel 16 so that the wires are exiting to the left. The wires can then be threaded through the hole in the back panel like so. The 2 major halves of our assembly can now be joined together. Ensure that they are aligned properly before the glue dries, paying particular attention to the 2 holes for the Skittle to pass through. There are just 4 more panels remaining to be fixed into place on our machine. The 2 number 21 panels are added in place to act as a funnel, whilst the number 20 sits in front of these to ensure that the Skittles do go down this funnel. Panel 6 is then gently inserted between the sides, with the cutout on the left hand side towards the hopper. This should not pinch the wheel tight, so ensure the wheel can still turn back and forth freely before you glue this panel in place. That's the bulk of our main assembly complete now. All we have left to do in the way of cardboard work is to use the remaining panels to assemble 5 of these cardboard pots, which is where we'll sort our Skittles into. For this, use some super glue to join the panels numbered 22 through to 25 inclusive together into 5 sets of these holders. That's all of our cardboard crafts complete now, so let's move on to our electronics. Prepare 4 lengths of 33cm long wires. Solder a separate wire to each of the pins marked VCC, ground, SCL and SDA onto our colour sensor. We can then set the colour sensor over the cutout on our machine. Before you do that though, take a look on the underside and notice where the LEDs and colour sensor itself are positioned. You want to centre these as much as possible over the cutout. Use some hot melt glue or similar to hold it in place. Turning to the servos next, cut just the brown and red wires from the back of the plastic connectors from each servo and then strip back some of the insulation. The wires coming from our servos are too thin to insert into our plastic connectors later. To get around this, we'll add a short 4cm length of wire to both the brown and red wires coming from our servos. The orange wire will be connected directly to our Arduino later. You should also add some insulation tape or heat shrink around our soldered connections. This is to help to prevent any short circuits. Let's prepare our contact switch next. For this, you're going to need a 25cm and 12cm length of wire. The long wire should be soldered to the central leg of the switch, and the 12cm wire to the leg at the end of the switch the metal arm is attached to. The next stage is important. We need to install the switch on the underside of our housing so that the wheel of the switch is against our cardboard wheel. The aim is to position the switch so that the switch is engaged whilst the wheel is turning until it comes across one of the 2 notches. Hold it in position and turn the wheel slowly by hand and listen for the action of the switch. Once you have found a position that works for you, mark it with a pencil and then return with some hot melt glue. Add a small amount onto the side of the switch and reposition where you marked out just now. Before the glue cools completely, keep turning the wheel and check that you have it in the right place. If you find it disengages the switch when it should not, then you can either reposition the switch or carefully add some thin strips of cardboard to the wheel to stop this. We can now start connecting some of the wires to our Arduino Nano. Taking the Arduino, solder the wire from the VIN on the colour sensor to 5 volts, the ground lead to ground, the SDA pin to pin A4 and SCL to pin A5. Next, the longer lead coming from our contact switch is soldered to D8 on the Arduino. Prepare an additional 14cm length of wire and attach one end of this to a spare ground pin on the Arduino. The orange lead coming from the servo which drives the wheel is to be connected to D5, and the orange wire coming from the chute servo connects to D6. This can be done by just placing the connector on the other side of the Arduino. We also need to attach a 5cm length of wire to each of the wires coming from our battery pack. The ends should also be wrapped in some insulation tape again. Add 4 AA batteries into the holder and you can glue it into the back of the bottom compartment with the wires exiting from the top. Now is the time to start bringing all of our wiring together. For this, we'll use the 2 blue plastic connectors. Take the first of our 2 wiring blocks and connect all of the power connections together from our battery and the 2 servos, these are all red leads, by pushing them into the terminal. Use the second connector to connect all of the ground wires together. That's one from our Arduino Nano, the brown wires coming from both of our servos, and the ground connection from our battery pack. You can then use some glue to hold our two connectors in place at the back of the machine. Let's work through setting up our software next. Later, we'll come back and tidy our wires using some glue, but for the time being, they're best left as they are. This way, if anything is wrong, it'll be easier to correct. Connect your Arduino to your PC using the USB cable. You can then download and open the code for this project in the Arduino IDE. Before we can upload the program though, we'll need to install a library for our color sensor. To do this, head to Sketch, Include Library, and go Manage Libraries, and then search for TCS34725 and install the Adafruit version. We can then check that we have the board type of Arduino Nano and the processor ATmega328P old bootloader. Once we've uploaded the code to our machine, you'll probably find that it will try to turn the Skittle wheel round once and have an attempt at scanning a Skittle and guessing its colour. That's fine, don't worry about that for now, but what we can do first is to place the chute in the bottom of our machine, as we now know where the position of the lower servo is. Press upload and open the serial monitor. Check that the baud rate is set to 115200 and that the adjacent drop down is set to no line endings. Once your code has finished uploading and the machine has finished moving, we can then place the chute, making sure it points straight away from the bay of our hopper. As your machine is probably ever so slightly different than mine, the next thing we will do is to calibrate your machine to recognise the Skittles it sees. To do this, take a handful of green Skittles and drop them into your hopper. We'll use these to check that the Skittles on the wheel are stopping directly underneath the colour sensor. Send a single character through the Arduino serial monitor and watch through the gap on top of your colour sensor. You should be able to see the colour change to a green light. This means that the sensor is well aligned with the Skittles. If your Skittle has passed the sensor, then you need to reduce the value for wheel overrun on line 11 in our code. And if it did not go far enough to reach the sensor, then you should increase this value. I've chosen green Skittles as when you have it aligned, you should see a green glow shine through the back of the sensor board. Now that we know our Skittles are lining up well under the colour sensor, we can set the values in our code to the right value for each Skittle. To do this, we'll take 5 readings of each colour and take an average of that. This is what we'll enter into our code. Working through the green Skittles in the hopper, send a keystroke through the Arduino serial monitor so that the machine picks one up and moves it towards the sensor. In the monitor, we will see it report the values which were scanned. Record these 3 values, which represent red, blue and green, and repeat this 4 more times. We can now add up these 5 columns and divide by 5 to get our average. Repeat this for each of the remaining coloured Skittles. You'll also need to take 5 readings from the machine running without any Skittles and take an average of that. This is how we'll know that we didn't collect a Skittle. Now we have all of our averages, we'll need to add them into the array in our code. The array starts at line 22. We need to enter the averages onto each line. So for my red Skittle, the values are 84, 78 and 82. Continue entering the others in the same fashion. Now that we've finished calibrating your machine, we need to update just one more value before we re-upload our code. And that's the value for the calibrating constant. Change this value from 1 to 0, which will let the machine run without waiting for any input from yourself, as well as make the output in the serial monitor more verbose, so you can see the decisions that our machine is making. You can now set out the 5 trays for collecting the Skittles, fill the hopper, and then enjoy your Skittles nicely organised. If you haven't subscribed to my channel yet, you'd make me a very happy chappy if you did. I hope you've enjoyed building your own Skittle sorting machine, and don't forget to take a look at some of the other projects on my channel such as this 3D printable Bluetooth remote controlled BB-8 and a 3D printed Simon Says game. Share this video with anyone you know who might like to build one of their own. Otherwise, until next time, ciao for now.